All right, welcome to The Explainer. Today, we are going to crack the code on something that is, well, it's totally fundamental if you want to write software that's clean, flexible, and powerful. We're talking about design patterns. Let's just dive right in.
Okay, let me ask you something. Have you ever built a piece of software that over time just becomes a total nightmare to change? You know what I mean, right? You start out, everything's clean, it's organized, but then you add a feature here, you make a tweak there, and suddenly your code is this tangled mess. A tiny change in one spot, bam, it breaks something totally unrelated. It's brittle, it's so frustrating, and yeah, it really feels like you've painted yourself into a corner.
Well, what if I told you there's a way out of that corner? And a pretty powerful one at that. This is exactly where design patterns come into play. Now, don't think of them as like ready-to-go code snippets. It's much better to think of them as pre-made blueprints. They are these proven, reusable solutions to the exact same problems that developers run into over and over again. The whole point is so you don't have to reinvent the wheel every single time.
And this quote, this really gets to the heart of it all. It says, instead of code reuse with patterns, you get experience reuse. And that's it. This isn't about mindlessly copying and pasting code. No way. It's about tapping into this huge collective library of wisdom, all the lessons that other developers learned the hard way. So you're not just reusing code, you're reusing experience.
Okay, so to get our heads around this, patterns are basically grouped into three main categories. First, you've got creational patterns. That's all about how objects are made. Then there's structural patterns, which is about how you put all those objects together to build bigger things. And finally, behavioral patterns, which cover how all these objects talk to each other and get stuff done. We're going to touch on all three, but let's start with how we build things.
All right, first up, structural patterns. Think of this as the flexible building category. The big question we're trying to answer here is, how do we put objects and classes together to make bigger systems without creating something that's impossible to change down the road?
Let's make this real with an example. Imagine you're coding up the ordering system for, say, Starbucks coffee. You've got your basic coffees, right? But then customers start asking for stuff. Can I get milk with that? And caramel on top of the milk? Ooh, and whipped cream. Can I get double milk? If you try to make a new class for every single combination, you're going to have an absolute maintenance nightmare. So, what do?
The answer is a really elegant structural pattern called the decorator. Here's how it works. First, you start with your simple, plain, base object. In our case, it's just a plain coffee. It's got a price, it's got a name, that's it. Nice and simple.
Okay, now, when a customer asks for milk, you don't go back and mess with the original coffee object. Nope. Instead, you wrap it. You literally wrap it in a milk decorator. This wrapper adds the cost of milk and adds milk to the description, all on top of the original coffee. And the best part? The original coffee object has no clue it's even been decorated.
And if they want caramel too, you guessed it, you just wrap it again, this time with a caramel decorator. You can just keep stacking these things, kind of like those Russian nesting dolls, to build up any combination you want, right when the order is placed. It's unbelievably flexible. And it's a perfect example of a huge design principle. Your classes should be open for extension, but closed for modification. We just added all this new functionality without touching a single line of the original coffee code. That's powerful.
Okay, so we've seen how to build things flexibly. Now let's switch gears and talk about behavioral patterns. This whole category is about making our objects smarter. Specifically, how they communicate with each other and how they get things done.
So let's look at another classic problem, this time from a duck simulator game. You create a main duck class. And, okay, all ducks can swim. That makes sense. But what about flying? A mallard duck can fly, obviously. But a rubber ducky? Not so much. See the problem? If you put a fly method in the main duck class, then every single duck you create, including the squeaky plastic ones, suddenly inherits the ability to fly. That's not right.
The fix for this is the strategy pattern. Instead of using rigid inheritance, which forces flying behavior on everyone, we use flexible composition. We basically find the part of our object that changes, in this case, the flying behavior, and we pull it out into its own separate family of strategy objects. So now a duck has a flying behavior instead of being a specific kind of flyer. This is a game changer because you can just swap out that behavior whenever you want just by giving it a different strategy object.
All right, here's another classic behavioral challenge for you. Picture a weather station. It's got all this data, temperature, humidity, pressure, and it needs to update a bunch of different screens. One showing the current conditions, another showing statistics, maybe a third with a forecast. So how does the main station tell all these displays that the weather has changed? Especially when you know you're going to want to add new displays later without having to rewrite the whole station.
This is a perfect job for the observer pattern. It sets up a simple one-to-many relationship. The subject, that's our weather station, keeps a list of all its observers, the displays, and notifies them directly when something changes. But it's worth knowing about a close cousin, the publish-subscribe pattern. The key difference here is that there's a middleman, like a message broker or an event channel. The weather station just publishes an update to the channel. The displays subscribe to that channel. They don't even know the weather station exists or that other displays exist. This makes things really loosely coupled, which is fantastic for big, complex systems where everything needs to work independently.
Okay, we've covered how to put objects together and how they should act. Let's wrap up with our final category, creational patterns. This is all about the very beginning, the process of how objects are actually born.
So creational patterns give you a ton of control over how objects get created. See, normally you might just sprinkle the new keyword all over your code. The problem is that ties your code directly to specific classes. Instead, you can use a pattern like a factory. Now, you don't create the object yourself, you just ask the factory for one. And the factory looks at the situation, maybe some configuration, and decides which specific class to create and hand back to you. It hides all that messy logic and makes your whole system way more flexible.
So let's pull it all together. We've looked at patterns for building things, for making things behave smartly, and for creating things in the first place. So what's the big idea? What's the real takeaway here?
You know, it all comes back to this idea. Design patterns aren't some strict set of rules you have to follow. They're not dogma. They're a shared language, a toolkit full of battle-tested solutions. They really let us stand on the shoulders of all the developers who came before us so we can avoid the same old mistakes and build software that's just better, more robust, more flexible, and way easier to live with.
So I want to leave you with this final thought. This whole idea of patterns isn't just for code, right? Think about it. A blueprint for a house, a recipe for your favorite meal, even the scientific method. These are all just patterns for solving common problems. So now that you kind of have this lens, what other blueprints do you see out there in the world around you?